Sorry, I got a little bit cut off there, but we were done with the problem anyways. We had moved the 36 back over and we had y equals all by itself, and that is vertex form. And that is all that this asked us to do. Now, number seven is the same type of problem. It just wants us to take it a step further. So it's negative 2x squared minus 4x plus 16. Okay? Negative 2x squared minus 4x plus 16. I'm going to go a little bit faster through this one because it uses the same exact steps that we just took on this one. So go back, make sure you've got those steps down a little bit, and then try to apply them to this problem yourself. That would be good practice. So first things first, we've got to have room for y. There was already an f of x there on the other side. We're just going to make it into a y on the other side. It's the same thing. Okay, y and f of x interchangeable. And we're going to subtract that 16 over because we don't want it over there on the left side with our x's anymore. Okay. Next, we want to make a equal 1. I wrote that over here on the left last time. Very similar way I'm doing this problem. To do that, we're going to have to factor out a negative 2. It's going to make that into a positive 2x. Okay, be careful there. And I know that this is already the step that I'm going to go ahead and write my boxes. Because I've created those parentheses, which means I'm ready to write some boxes in there. To figure out what goes in those boxes, I need to do 2, which is my b term right here, right there, 2, over 2 quantity squared. Well, that's just 1 quantity squared, which is just 1. That's what's going in on that left side, 1. And now I have to make sure I balance that out, okay? To balance it out, I multiply the number out back or out front by whatever I added. So I didn't really add a 1 to this left side. I actually added a negative 2 times 1, which is a negative 2, and that's what I need to add to my right-hand side. That makes the balancing with the weights, analogy a little bit less useful because you don't balance negative weights out, but you still get the gist of it. If we added a 1 times negative 2 to the left, we have to add that same 1 times negative 2 to the right, okay? Now this is our perfect square trinomial. I told you on the last one I was going to show you the long way to do it. On this one I'm just going to use the shortcut. Negative 2 is out front. This would be x because this is square root of the first term, the sine of the middle term, and the square root of the last term. Quantity squared equals y. Minus 16 minus 2 is just minus 18. We're going to add that 18 back over. So even though we took it away to begin with, we actually want it back over in the end. We're going to have negative 2 x plus 1 quantity squared equals y. Okay? Oh, I'm sorry. I just said we were adding that 18 back over there, and I completely forgot all about it. Don't do what Mr. Sorrell did. Don't forget that 18. Okay? Equals y. Now, last problem, that's all we needed. But this one, we need the vertex and the axis of symmetry, okay? So, to find the vertex here, our vertex is always some point, x comma y. And just like with our earlier in the test on the first problem, we know we need to flip this one, giving us negative 1. But we keep the sign of this one, meaning our vertex is at negative 1, 18. Now, just as a little kind of lesson reminder of what an axis of symmetry is. It's always a vertical line for our parabolas that split them in half. So, just as a quick guess around, this is at negative 1, 18. Well, this parabola had a negative number out front, meaning it opens downwards, which means it has a maximum. I don't know what this parabola is going to look like, but I'm going to just guesstimate it somewhere right like that. Because here's my vertex of negative 1, 18, and it opens downwards. It might be skinnier than that because of the stretch, but I don't know. That's really not of concern. What I'm talking about is this axis of symmetry. If I wanted to split this parabola in half, I would have to draw that vertical line right through the vertex. And I know that the equation of any vertical line is always x equals a number. Well, I know what that x has to equal because it's part of my vertex. That x has to equal -1. So my axis of symmetry is always going to be x equals whatever the x value of my vertex is. So I wrote it in factored form, found the vertex, found the axis of symmetry. Tomorrow, these will have show your work written on them, okay? You cannot just get away with doing it in the calculator. You have to show me you can do this by hand. Now, if you can't do it by hand by tomorrow for whatever reason, then at least answer the questions you can answer. You can answer these with the calculator. But if all you do is write your answers from the calculator on there, know that you're not going to get a large bulk of the credit, okay? Number 8, write the quadratic in factored form given the x-intercepts. Guys, we just went from some really, really hard problems to a really easy problem, okay? Please don't get lost and just be like, I don't know how to do any of this test. I give up. I can't learn any of this. This one you know. I promise you know this one. And if you don't, you may have missed that day or something. You can pick up on it really quick, okay? Think back to our very first problems. We had factored form, and then we got the zeros by flipping the signs. Now we've kind of just got to mimic this, but in reverse order, because we're starting here with the zeros and going back. Guys, if you can answer this first ABC question correctly, you can use it as a reference point for the rest of the test. We've already seen one place that was a reference point. Now we're seeing another. We also just did vertex. Like this first question is kind of like your little map to the rest of the test. So we now have the zeros, and we need to work backwards to get the factored form. Well, that just means we reflip the signs. But factored form has these x's in it. It's always these binomials. And this was a +5, which means we had to unflip it. And this was a -2, which means we unflip that into a +2. And this would be factored form. Just to be safe, you might want to label it something like f of x or y equals, okay? That's not really a requirement, just to be safe, okay? Number 9, another problem that if you got through that front half of the test, you're like, I don't know any of this, I'm just going to guess, I'm going to leave it all blank. You're going to miss number 9, and you shouldn't, okay? Number 9 is that axis of symmetry. Now, if you just remember the formula here, there were 2 formulas for this. And one of them was given 2 symmetric points. That's the one the EOC seems to love because it's just kind of a random do you know the form trick. Well, what it is x of 1 plus x of 2 divided by 2. Okay? Now, where that comes from is a parabola. Let's say our parabola is over here. Why not? Just randomly made one up. I'm just trying to explain this. Okay? This parabola is going to have points 2, 0, and 8, 0. And it wants to know, hey, where is that axis of symmetry? Well, that axis of symmetry has to be right smack dab in the middle of them. It has to be the same distance away. So that's what this is kind of doing, is it's in a way averaging these 2 x values, okay? But really, you could also do this without even remembering the formula. You could think, okay, what's really right dead center in the middle of 8, or middle of 2 and 8? Well, 2, 3, 4, 5, 6, 7, 8. Those are my x values if you listed them out. Looks like 5's dead center of those, which would be the 0.50. But I wouldn't rely on that though. But anyways, if you boil it down to that, just kind of thought of where they'd be on a graph, you could figure that out. But right here we know if we follow this formula, it's 2 plus 8 over 2. Okay, because this is my x of 1, that's my x of 2, which is 10 over 2, which is 5. And now, I would love to give you credit for this, guys, but if you give me just a regular old 5 tomorrow and you box it in, it's not right. It's going to be some good partial credit, but it's not right. Because an axis of symmetry is a line. Always it's a line, which means you have to write it like a linear equation. And in this case, we still need that 5, but your answer should be x equals 5. As in this vertical line that includes all of the y values at the x value of 5.